Hey everybody, how's it going? Well, we are almost done with the first half of Unit 2. We've got one target left. We spent a lot of time in Target 1 working on solving all types of different equations. And I'm just chilling here in the math office with my friend Will. Say hi, Will. Over there, that's Tom, finishing up a test. Miss Rouser in the background.
Hi, guys.
Yep, she's saying hi. So you can see the gang's all here, so why don't we do some math, right? And here's the good news. A lot of the stuff that we're going to be doing in this unit is not going to be about actually solving our equations. It's going to be about translating, about writing. And we've done some of this before, right? Because all an equation really is two expressions joined together by an equal sign. So what that means is all of the language that we learned about our expressions in Unit 1, we're going to be bringing that back when we talk about our language in equations. However, we still do need to make sure we remember these. So what I want you to do is to take all of these phrases and look at them. Pause the video and look at them and write down any of them that you know have given you trouble in the past and kind of focus on those. I'm sorry, guys. I keep saying don't show this message again, and it keeps coming back. And focus on these and make sure you really have them down. Ready? Pause. Okay, so you've identified the ones that have given you trouble in the past, and we're not going to let them do it again when the test comes up for our equation language. There are a few more, though, that we need to add to this list, because now they're not just expressions, they are equations. So we need to know language to communicate about an equal sign, right? So if we have this equation here, x plus 2 equals 8. Well, we can obviously use the word equals, but there are some other words as well, such as the word is. We could say a number plus 2 is 8. We could say, like we said, a number plus 2 is equal to 8. We could say a number plus 2 is the same as 8. Or we could say a number plus 2 is equivalent to 8, right? So we've got all of those different options here to use language for communicating that we want to be writing an equal sign. Well, when we take everything we had in Unit 1 and combine it with that, we're ready to go. So here are 4 phrases that are written in words that we want you to translate into numbers, variables, and symbols. So go ahead, pause the video, and give it your best shot now. Pause. Let's see how you did. So we can see we get 4x plus 7 equals 24. And number 2, we need to put parentheses around the x minus 12 because we have the quantity of there. In 3, you can see we have a variable actually on both sides of our equal sign, and that's going to happen now. And then in 4, we're using our fractional language, 1/3 of 7/5, things like that in our equations here. Again, if you have any questions on these, if any of the language just doesn't make sense to you, please make a note of that in your notes. Put a big question mark there so you can ask in class. Well, we've talked about how if you can only translate in one direction, that's not very useful. If all I can do is translate from Spanish to English, but I can't go from English to Spanish, I'm going to be in a lot of trouble. Same way with math. Not only do we have to be able to read a phrase or a sentence and translate it into numbers, symbols, and variables, excuse me, guys, we have to be able to take a algebraic expression that is numbers, symbols, and variables and translate that into a sentence. So we could actually speak and communicate that to somebody else. So why don't you go ahead, pause the video, and try and come up with a sentence that would explain, would express these equations now. Ready? Pause. Okay, let's take a look and see how you did. Now remember, when we're using a language, when we're writing things out, there will be more than one possible correct phrase or sentence for each expression. So if yours don't match mine exactly, that's okay. You very well might have a perfectly correct phrase there or sentence that would describe the equation. If you're unsure of whether yours is okay, please make sure you make a note and ask in class, and we'll be happy to go over everything. Well, now we're going to kind of really dig into what we would consider a word problem. Before, we've kind of just been doing what we kind of working on translating mathematical language. But when we actually start having word problems, this is when we take real life situations and we start working on how do we use math to solve problems in real life situations. Now, some of these you're going to see are a little silly to have a little bit of fun, and some of these maybe are a little simple because we haven't learned enough math to be dealing with full kind of real life situations. But these are kind of our stepping stone word problems, and eventually as we learn more and more, we'll be able to build up to more lifelike situations. So in the first one, we can see Dan started selling leprechauns. Right now, he can sell a leprechaun for $60 a piece. I know that sounds pretty cheap, but they're just not as nice and clean and friendly as you think they are. So that drives the price down a little bit. But it costs him a shipping fee of $500 to bring him over from Ireland. If he made a total of $1,520 selling the leprechauns, we want to know how many did he actually sell to get that amount. Well, to figure this out, we can write an equation. We can see that 1,520 is the total, so that goes on one side of the equation by itself. Now, for every leprechaun he sells, which is an unknown amount, so that's why it's a variable there, you can see X, we made the number of leprechauns X, he makes $60. So his profit is 60 times the number of leprechauns he sells, or X. But it does cost him $500 to have that shipment of leprechauns sent over to him, right? So that, because it's a cost to him, that's taking away from his profits. So his profit, 60X, has to be, we have to subtract 500 from that to have that set equal to his total amount of money he made, which was $1,520. This equation we now could solve, and we could actually figure out the number of leprechauns Dan sold. All right, let's try another one here. Amber is looking for some new clothes, right? So she saw some alligator skin shoes that she decided she had to have. The shoes cost $30 a piece, pretty good deal for alligator skin, I know, right? And she's got $360 to spend, or that she did spend. So how many shoes did she buy? Well, again, we have a variable here. We don't know how many shoes she bought, but we know how to figure out how many she bought by using an equation. We know each pair of shoes costs $30, and 30 times the number of shoes will give us the total cost of $360. Right? You can see that 30x equals 360 would be an equation we could solve to find the number of shoes. Notice, when I'm working with word problems, it is very important that you label your variables. When you put a variable into an equation, which is modeling a real-life situation, you've got to make sure that you label what that variable is. Well, we've done a couple together, so why don't you read these and try these on your own. Ready, pause. Okay, let's see how you did. Did you get 5x plus 55 equals 335 for Max, and x plus 67 equals 213 for Cassidy? Well, if you didn't, please make a note of that and come to class and we'll talk about it. We'll make sure we figure that out. Well, that brings us to the end. Well, I hope you were the home team and you came out of this video on top. We'll see you in class.